Hello friends, myself Vishnujay, currently studying in Sri Venkateswara College of Engineering. Subject is Maths, topic is the ANOVA Technique. Introduction to Analysis of Variance, ANOVA. Examining group differences. ANOVA helps determine if there's a statistically significant difference between the means of two or more groups. This is achieved by comparing the variability between groups against the variability within groups. Analyzing variance. Instead of directly comparing means, ANOVA focuses on analyzing the variance within each group and the variance between the groups. This variance analysis helps us understand the impact of different factors on the outcome. Versatile tool. ANOVA is incredibly versatile, applicable in various fields like healthcare, engineering, social science, and business. Assumptions of ANOVA. Normality. ANOVA assumes that the data within each group follows a normal distribution. This assumption can be checked using various statistical tests, such as the Shapiro-Wilk test. Homogeneity of variance. The variance of the groups being compared should be equal. This assumption can be checked using the Levens test or Bartlett's test. Independence. Observations within each group must be independent of each other. This means the data points should not be related or influenced by each other. One-way ANOVA. One factor. One-way ANOVA examines the effect of a single independent variable on a dependent variable with two or more levels of the factor. Comparing means. It compares the means of the group creates by the different levels of the independent variable to see if there are any significant differences. Example, a researcher might use one-way ANOVA to compare the effectiveness of three different types of medication on the blood pressure. Interpreting one-way ANOVA results. F statistics. This measures the ratio of between group variance to within group variance. A larger F statistic suggests a greater difference between group means. P-value. The p-value represents the probability of observing the data if there were no differences between group means. A p-value less than a significance level. Example 0.05 suggests a significant difference. Post hoc test. If the ANOVA results in significant post hoc test like Turkish HSD can be used to identify which specific group differ from each other. Two-way ANOVA, two factors. Two-way ANOVA analyze the effects of two independent variables, factors on a dependent variable, with each factor having two or more levels. Interactions. If not only assesses the main effects of each factor but also examines the interaction effect where the effect on of one factor may defend depending on the level of the another factor. Example, researchers could use two-way ANOVA to investigate the effects of exercise intensive, low, medium, high, and diet type vegetarian, omnivorous on weight loss. Interactions in two-way ANOVA combined effect. An interaction effect occurs when the effect of one factor on the dependent variable differs depending on the level of the another factor. Visual interpretation. Interactions are often visualized using line graph. If the lines are parallel, there's no interaction effect. If the lines insert or have different slopes, an interaction is present. Meaningful insights. Interactions provide value insights. For instance, a meditation might be more effective for one group than another, depending on their age or pre-existing health conditions. Advantages of ANOVA. powerful and versatile. ANOVA is a robust tool for analyzing data from a wide range of experiments, surveys, and observational studies. Effective analysis. It allows researchers to analyze multiple factors and their interactions simultaneously, making it efficient for exploring complex data. Statistical efficiency. ANOVA helps determine whether observed differences between groups are statistically significant, providing a solid foundation for drawing conclusions. Limitations and considerations. While ANOVA is powerful, it has limitations. It assumes normality and homogeneity of variance, which might not always hold true in real world data. Additionally, the interruptions of interactions effects can be complex. Consider the assumptions of the model and carefully interpret results, especially in the presence of interactions or when the assumptions are violated, while ANOVA pa- partitions variability into between groups and within groups components. It doesn't provide insights into the cause of variability within groups. Unequal group size can lead to biased results, particularly if the variance differ across groups. Conclusions from ANOVA. The conclusion of an ANOVA test typically falls into one of two categories. If the p-value is less than the significance level, it suggests that at least one group means differs significantly from the other. However, further analysis is needed to identify the specific differences. If the p-value is greater than the significant level, there is insufficient evidence to conclude that the group means differ significantly. This does not prove that all means are unequal, but indicates that no significant difference were detected under the given conditions. Thank you so much for watching my video.